Hello, everyone. Let me start recording the session. Give me 1 second. Okay, yeah, meeting's recording. Um, Good morning, everyone, and welcome to today's webinar hosted by Netcon Americas and F&T Software. Thank you for taking the time out of your busy schedules to join us and explore this highly relevant topic, especially in today's telecom and IT landscape, which is data centers. In this session, we will cover the current market trends and outlooks, sharing practical strategies to optimize space, power, and cooling, and conclude with a live demonstration of the F&T Command DCIM solution. So FNT is helping many organizations efficiently manage and operate their critical infrastructure and services within data centers, telecom, and IT networks. So before we get started, let me briefly introduce myself. My name is Eduardo Langrafe. I'm Operations Director for our OSS business unit at Netcon Americas. I bring over 25 years of experience in the telecom, IT, and software industries, supporting data centers, carriers, ISPs, and utilities in their digital transformation journeys. Joining me today is Brian Clines from F&T Software. Brian, thank you for accepting our invitation to be part of this webinar. I will now hand it over to you to introduce yourself to the audience.
Thank you so much, Eduardo, for having me. My name is Brian Clines. I am the lead pre-sales engineer for FNT Americas. I've had the opportunity to work with many of our existing data center customers and as well as new potential ones, and I've gotten to see a lot of the struggles that we're going to talk about firsthand. So I'm really looking forward to presenting to you guys today. I'm just going to take us to the next slide for a couple guidelines before we begin. Eduardo, if you want to mention anything here.
Yes, so before we dive into the content, I want to take just a few moments to a few housekeeping items so we can make the most of our time together today. First, the microphones will remain muted throughout the session. Second, questions are absolutely welcomed. We have set aside a dedicated time at the end of the session specifically for Q&A. Please use the Q&A panel in Microsoft Teams to submit your questions at any point during the session. We will collect all questions as we go and address them together at the end. So third, live captions and translation. If you prefer to follow along in Portuguese, Spanish, or another language, Microsoft Teams live captions are enabled for this session. So to turn them on, click More in your Teams toolbar and select Turn on Live Captions. From there, you can choose your preferred language for real-time translation. So we want this to be as accessible, as useful, and as possible for everyone joining us today, whether you are in US, Brazil, Europe, Latin America, or anywhere else in the world. So without further ado, I will hand it over to Brian Clines for the first part of this webinar, and we'll come back later for the live demo of FNT Command.
Thank you very much, my friend. And now I will officially begin. So welcome, everyone, and thank you for joining us today. Over the next hour, we're going to talk about something that keeps a lot of infrastructure leaders up at night, the growing gap between what AI demands from data centers and what our current infrastructure can actually deliver. We're calling this briefing Mastering Data Center Capacity Optimization 2026, and the timing is deliberate. We're at an inflection point. Power, cooling, and physical space constraints are no longer future problems. They are converging right now, threatening the 2026 pipeline of projects across every major market. But this isn't a doom and gloom session. We're going to walk through real bottlenecks and then, more importantly, the integrated strategies that the operators are deploying today to stay ahead of the curve. Let's get into it. So let's start with the scale of what we're dealing with. By late 2025, there were 23 gigawatts of data center capacity under active construction globally. That is a historic build-out, driven almost entirely by AI and high-performance computing demand. But here's the problem. Up to 50% of the 2026 planned pipeline is at risk of slippage or outright cancellation. Not because of lack of demand has never been stronger, but because of power and permitting constraints that operators simply cannot work around fast enough. In prime markets, the average wait time to connect to the grid is now over 4 years. 4 years. That means a hyperscaler breaking ground today cannot get grid power until 2030 through traditional channels. And utilization rates in major markets are climbing towards 95%. The buffer that operators once relied on to absorb demand strikes is essentially gone. This is the environment we're operating in, and it demands a fundamentally different approach. If there's one constraint that towers above all others right now, it is power. A single large AI facility can demand 300 to 500 megawatts. To put that in perspective, that's comparable to the electrical load of a mid-sized city. And the grid was simply not designed to absorb that kind of demand at the pace AI is creating it. In the most competitive markets, Northern Virginia, Silicon Valley, London, Singapore, Frankfurt, interconnection queues now exceed 4 years. Substations need upgrading, transmission lines need expanding, and none of that happens quickly. So what are the hyperscalers doing? They're not waiting. They're pivoting to on-site generation, natural gas, renewables paired with storage, and structuring bring-your-own-power contracts that bypass the grid queue entirely. For everyone else, the co-location providers, the enterprise operators, the message is the same. You cannot assume grid power will be available when and where you need it. Power strategy has to be part of your capacity strategy from day one. Now, let's talk about cooling, because this is where physics get brutal. AI racks today routinely operate at 50 to 100 kilowatts. Next generation GPU clusters are pushing chip thermal design power beyond 1,000 to 1,400 watts per chip. Traditional air-cooled infrastructure was designed for 10 to 25 kilowatts per rack. That's not a gap that you can close with better fans. Here's what happens when you try to push air cooling beyond its limits. Thermal throttling kicks in. Your GPUs slow themselves down to avoid overheating mid-job. You're paying for compute you're not getting. Hardware failure rates climb. Refresh cycles accelerate, and your cooling systems are consuming 30 to 40% of total facility power just to keep up. The hard truth is this: legacy cooling infrastructure cannot be patched, it has to be replaced. And the longer operators wait, the more they're leaving performance and efficiency on the table, while also drawing regulatory scrutiny for excessive energy and water consumption. This is the burning platform, and the solution is liquid cooling, which we will get into shortly. Beyond power and cooling, there's a third constraint that doesn't get enough attention: space, and the cost and complexity of creating more of it. Land near power-rich locations is increasingly scarce and expensive. Environmental and zoning permits are taking longer than ever, and skilled construction labor, such as electricians, mechanical contractors, low-voltage specialists, is in short supply in every high-growth data center market globally. But perhaps the most underappreciated problem is stranded capacity. Operators built out infrastructure, power circuits, cooling headroom, rack slots, and then discovered that the actual IT load didn't match what was deployed. You end up with expensive infrastructure sitting idle, or worse, allocated on paper but never actually consumed. This is a capital efficiency crisis as much as a physical one, and it's why the answer isn't simply build more. The answer is optimize what you have, eliminate the waste, and then, only then, build what you actually need. That's the philosophy we're going to carry through the rest of this session. Let's talk about the external pressures that are reshaping how this industry operates. Energy and water consumption at data center scale are now firmly in the crosshairs of regulators, ratepayers, and ESG-driven investors. We're seeing carbon reduction mandates, efficiency requirements, and community pushback that are directly affecting how new capacity gets permitted, and in some cases, whether it gets permitted at all. At the same time, OpEx and CapEx are both soaring. Power and cooling dominate the cost stack. Operators who fail to improve their efficiency metrics are going to face margin compression, and as reporting requirements tighten globally, reputational risk as well. This is why the three efficiency metrics on this slide matter so much. PUE, power usage effectiveness, is the foundational ratio. Leading facilities are now targeting 1.2 or below, which we will get into much more detail about soon. WUE, water usage effectiveness, is under growing pressure as drought risk rises in key markets. And ERE, energy reuse effectiveness, is increasingly a differentiator, measuring how much waste heat is being put into beneficial use. These aren't just compliance metrics, they are competitive metrics, and the operators who master them will have a structural cost and regulatory advantage going forward. Before we move into solutions, I want to pause on this principle: optimize first, build second, because it's the lens through which everything else in this session should be viewed. In 2026, capacity optimization doesn't mean building more data centers. It means extracting maximum compute performance from the infrastructure you already have or are already planning. The focus shifts to utilization, density, and efficiency as the primary levers. Why? Because new builds take years. They require power that may not be available. They require permits that may not be granted, and they require capital that could be deployed far more efficiently against existing assets. The operators who are winning right now are the ones who looked at their existing footprint and asked, how much more can we get out of this? How do we eliminate stranded capacity? How do we increase density without adding square footage? That's the mindset shift. And now let's look at the specific strategies that make it real. Now we're into solutions, and we start with power because it's the number one constraint, so it has to be the number one optimization target. There are three levers here. The first is architecture, high voltage central busways, DC distribution, modular UPS, and transformer configurations. These aren't just engineering preferences. They deliver superior efficiency at partial load, which is where most facilities actually operate most of the time. And they eliminate the costly overbuilding of static electrical infrastructure that has plagued traditional designs. The second lever is real-time power management, power capping, dynamic voltage and frequency scaling, AI-driven workload placement. These tools can reduce stranded power allocation by 20 to 30% in dense deployments. That's not a rounding error. That's a meaningful reduction in both cost and carbon intensity. The third lever is on-site and hybrid generation. Behind the meter natural gas, renewables paired with battery storage, peak shaving, these approaches bypass the grid queue entirely. They also improve resilience and provide cost predictability on the grid-dependent operators simply cannot achieve right now. The message is clear. Don't wait for the grid, build your own power strategy. If power is the number one constraint, cooling optimization is the number one solution lever, and the data on this slide makes that case clearly. Look at the progression. Legacy air cooling, 10 to 25 kilowatts per rack, PUE of 1.5 to 1.7, high water use. That's where most of the installed base sits today. Rear door heat exchangers get you up to 30 to 50 kilowatts per rack and a PUE of 1.3 to 1.5, and they're retrofittable, which makes them a practical first step. Direct-to-chip cold plates can take you from 50 to 100 kilowatts per rack with a PUE of 1.2 to 1.3. That's the sweet spot for most AI deployments today. And full immersion cooling, submerging servers in dielectric fluid gets you 100 plus kilowatts per rack with a PUE below 1.05 and a 90% reduction in water consumption. These gains are not incremental. Moving from a PUE of 1.7 to 1.2 means reclaiming roughly 30% of total facility power that was previously wasted on cooling overhead. For a 100 megawatt facility, that's tens of millions of dollars in annual operating savings. The transition to liquid cooling is no longer a future consideration. For AI infrastructure, it is the present requirement. Let's go a level deeper on the three primary liquid cooling technologies, because the choice between them is not a one-size-fits-all. It depends on your existing infrastructure, your density targets, and your timeline. Direct-to-chip cold plates are the workhorse of the current AI deployment wave. Coolant circulates directly to CPUs and GPUs via metal cold plates. You remove 70 to 80% of more heat efficiently. You can support 50 to 100 plus kilowatts per rack, and you dramatically reduce your dependency on room-level airflow. This is the technology most hyperscalers are standardizing on for new AI builds today. Rear door heat exchangers are the pragmatic retrofit option. They capture heat at the rack exhaust before it even enters the room. They're hybrid friendly. You can layer them onto existing air-cooled infrastructure without a full facility redesign. If you're managing a legacy estate and need to increase density in the near term, this is often your fastest path forward. And then there's immersion cooling, single phase and two phase. Servers are submerged in dielectric fluid. You achieve the lowest possible PUE, sub 0.105 is achievable. You eliminate most air handlers, and you reduce water consumption by up to 90% compared to evaporative cooling. The operational model is different, and the upfront investment is higher, but for dedicated AI zones, the economics are increasingly compelling. The right answer for most operators is a hybrid of all three, matched to the specific zones and workloads within their facility. Our third and final solution chapter is space optimization. And this is where density intelligence come together. The first move is a high-density rack deployment, transitioning to 30 to 100 plus kilowatt racks with optimized hot-cold aisle containment, vertical PDUs, and disciplined cable management. Even in liquid-cooled environments, residual heat from ancillary components still needs to be managed. Density without discipline creates new problems. The second move is modular prefabricated design. Factory-built modules replace on-site labor requirements, which, as we discussed, are in short supply. They compress deployment timelines and they support easier retrofits as workload requirements evolve. For operators who need to expand capacity quickly, And the underpinning of all this is the software-defined infrastructure. Pooling compute, storage, and networking dynamically with policy-based provisioning and predictive capacity planning that closes the gap between what's allocated and what's actually consumed. Space optimization isn't about building more. It's about using what you have with far greater precision. Everything we've discussed so far, power optimization, cooling optimization, space optimization, these are powerful in isolation. But the operators achieving the greatest efficiency gains are the ones treating their data center as a single integrated organism, not a collection of independent silos. That's what this slide is about, integrated operations. It starts with integrated design, power, cooling, IT, and controls designed as one system from day one, not bolted together after the fact. When these systems are co-designed, you eliminate the inefficiencies that arise at the boundaries between them. Then you layer in AI-driven operations, policy-based provisioning, predictive failure detection, dynamic energy optimization running continuously, not quarterly reviews, continuous automized optimization. And the third is relentless KPI tracking, PUE, WE, CUE, ERE, tracked in real time, not quarterly reports. Anomalies trigger automated responses. You can't optimize what you don't measure, and you can't measure fast enough with manual processes. Finally, heat reuse and sustainability. Waste heat recovery for district heating or absorption cooling transforms what was a liability, heat you had to get rid of, into a community asset. This is increasingly a differentiator in markets where community relations and sustainability commitments affect permitting outcomes. The cycle on this slide is intentional. These four enablers reinforce each other. Together, they represent the operating model of the leading data center operators in 2026. Let's put some hard numbers on the efficiency opportunity, because this is where the business use case becomes undeniable. The bar chart on this slide shows PUE by cooling system type. Legacy air-cooled, 1.7. Optimized air-cooled, 1.5. Hybrid air plus rear door heat exchangers, 1.35. Direct-to-chip liquid, 1.2. And full immersion, 1.05. Now, PUE measures total facility power divided by IT load power. A PUE of 1.0 is theoretical perfection. Every single watt serves compute. In practice, the overhead of cooling and power distribution always adds some inefficiency. The question is how much? Moving from 1.7 to 1.2 means reclaiming roughly 30% of total facility power that was previously wasted. For a 100 megawatt facility, as we mentioned, that delta represents tens of millions of dollars in annual operating cost savings and a proportional reduction in carbon intensity before you even factor in renewable energy procurement. For a 500 megawatt hyperscale campus, we're talking about hundreds of millions of dollars over a decade. That's not an efficiency project. That's a strategic imperative. And this is why the investment case for liquid cooling, even with its higher upfront cost, is increasingly straightforward. The payback periods are compressing as energy costs rise and as the performance gap between air and liquid cooling widens with each new GPU generation. So how do you actually get from where you are today to where you need to be? That's what this roadmap is all about. The key insight here is that retrofit sequencing matters. You cannot transform a data center overnight, as much as we wish we could, but a structured phased approach delivers measurable wins at each stage while positioning the facility for full AI era workloads. In the immediate term, the next 0 to 6 months, the focus is on quick wins with high impact. Deploy real-time capacity management software, implement hot-cold aisle containment, audit and eliminate stranded power allocations, upgrade to high-efficiency 415-volt distribution where feasible, These actions cost relatively little and deliver immediate operational improvements. In the near term, 6 to 18 months, you start the cooling transition. Install rear door heat exchangers in your highest density zones. Deploy AI-driven cooling controls and economizers. Begin on-site generation feasibility studies. Standardize rack configurations and cable management. In the medium term, 18 to 36 months, new builds go direct-to-chip liquid cooling as standard. Modular prefabricated units are deployed. Behind-the-meter power agreements are finalized. Waste heat recovery pilots begin. And in the long term, 36 months and beyond, full immersion cooling AI-dedicated zones, software-defined infrastructure across the full estate, sustainability certifications and heat reuse agreements with local utilities or municipalities. The point is, start now. The operators who begin phase 1 today will be in phase 3, while the competitors are still in phase 1. Let's close with the big picture and the stakes. Global data center capacity could double by 2030. AI adoption is continuing to outpace even the most aggressive forecasts. The demand is real, it's accelerating, and it is not going away. The operators who will win in this environment are the ones who master integrated power, cooling, and space optimization today, not in 2 years. Because in the competitive advantage that comes from lower PUE, higher density, and energy independence compounds over time. It shows up in cost structure, in carbon credentials, and the ability to serve next generation workloads that competitors can simply not accommodate. The 4 imperatives on this slide are your action agenda. Optimize existing assets before committing to new builds. Adopt liquid cooling for AI workloads. Secure your own power. Grid dependency is a structural risk in prime markets. And integrate and automate. Treat power, cooling, and IT as one system managed by AI. Those who do not act on these imperatives will find themselves capacity constrained, margin compressed, and outpaced by operators who did. Thank you for your time today. We're happy to take questions, and if you'd like to go deeper on any of these topics, our team is available for follow-up conversations. So we've spent the first half of this session so far talking about the constraints, power, cooling, and space, and the strategies to address them. But here's the hard truth. None of these strategies are executable without visibility, and visibility is exactly what a mature DCIM platform provides. Without a unified system like FNT Command, operators are essentially flying blind. They're making capacity decisions based on spreadsheets, tribal knowledge, and outdated asset records. In a 2026 data center environment where a single miscalculation on power allocation could cascade into a thermal event or stranded multi-million-dollar investment, that is simply not acceptable. So what does FNT Command actually give you? First, full infrastructure visibility. FNT Command brings IT, facility, power, and cooling data into a single integrated model. You get 2D and 3D visualization of racks, rooms, and floor space across multiple locations, all from one platform. No more siloed systems, no more blind spots. Second, real-time capacity and power management. Live monitoring of power, cooling, and space utilization means you can detect anomalies before they become outages. You can see exactly where stranded capacity exists and reclaim it. And you can track PUE in real time, not a quarterly report. Third, strategic planning and scenario modeling. Before you commit to a new high-density AI deployment, FNT Command lets you model the impact on power and cooling using historical data. You validate the plan before a single cable is touched. That's the difference between reactive and proactive operations. And fourth, process automation and operational efficiency. Provisioning workflows, change management, compliance reporting. FNT Command automates the daily operational burden that consumes your team's time and introduces human error. Your engineers focused on strategic work, not manual documentation. The insight at the bottom of this slide is worth repeating. Organizations using mature DCIM solutions report up to 30% reduction in stranded capacity. That's not a marginal improvement, that's a fundamental shift in how efficiently your infrastructure operates. DCIM is not a nice to have. In 2026, it is the operating system of the modern data center. All right, this is the moment we've been building towards. Everything we've discussed today, the power constraints, the cooling challenges, and the stranded capacity problem, the need for real-time visibility, all of it comes together in a platform like FNT Command. And rather than tell you more about it, I want to show you. What you're going to see is a live FNT command environment. This is not a recorded demo or slide deck. This is the actual platform running live. We're going to walk through 5 areas together. Eduardo, if you want to cut me off at any point because you're doing the demo, feel free, but if not, I will pass it over to you shortly. First, the data center cockpit, the command center view. You'll see real-time power, cooling, and space utilization across the facility at a glance. This is the dashboard that operators use every day to stay ahead of the capacity issues before they become incidents. Second, we'll navigate the 3D floor and rack visualization. You'll be able to see exactly how assets are physically laid out, drill into individual racks, and trace the relationships between IT equipment, power feeds, and cooling circuits. And third, we'll run a capacity planning scenario, specifically modeling what happens when you add new high-density AI rack deployment. FNT command will show you the predicted impact on power and cooling before a single cable is touched. Fourth, we'll trigger an automated workflow, a provisioning request, and watch the system handle the checks, approvals, and documentation updates automatically. Fifth, we'll pull up a KPI reporting dashboard, PUE, WE, utilization trends, and show how that data can be exported in real time for stakeholder reporting. Feel free to ask questions at any point during the demo, and at this point, I would like to officially hand over back to Eduardo to show you himself. Thank you, everybody, for your time so far.
Very good, Brian. Thank you very much for such a great presentation on data center and how to optimize the resources. Let me make sure I'm going to share my screen, and I'm happy that we also have more than half an hour so I can do like a slow deep dive into FNT Command Platform, which is a great software for DCIM, telecom, and IT management. First, I would like to start saying that FNT Command is fully web-based, and it's also developed on cloud-native technologies, which it makes it very cost-effective for the implementation, whether in on-premises environment, in your own infrastructure, or whether on a SaaS environment. So we can offer the system on both options as you prefer. So FNT has been around for more than 30 years, developing the technology, improving, always adding more value into what customers can get from it. This is FNT Command Mobile. We will take a look on it. It gives field technicians, remote users, full control of the IT and network and data center infrastructure. So we will take a look at the web or the mobile at the end of the demo. And I have here the command web interface. So first of all, I would like to start by saying that the software is sold, and it's also configured based on specific modules. So we get the C-based modules, and the modules themselves, we call it capabilities within FNT. So we get the C-based capabilities where we have everything that will allow you to manage your assets, to manage your network resources and visualize them as well as plan. And within the C-based capabilities, we also have the access management, so giving users permissions to what they want to or they can see in the software. FNT is also a, let's say, multi-tenant system, so you can have a single platform managing different data centers, especially if you are like an engineer and construction company dealing with multiple companies. You can really use FNT as this multi-tenant, giving your own customers access to visualize the infrastructure in real time, okay? We also have within C-Base the administration modules. So I will just give you a quick overview on how easy it is to import data into FNT command. And entity manager, this is related to customizing the data model. So being flexible to allow you bring any type of information that is relevant for your operation is also key in FNT command. And that kind of customization and flexibility is given by the platform. And even though we have let's say, the capabilities sold individually, we normally bundle them in packages, right? So we get the C-based bundle where you can get all of these capabilities in your software. We will explore a little bit more about them in a few moments. Then we got the C-line. This is where we start connecting the assets in a consistent way. So not only now I got my server with all its information, but now I see how ports are connected. So C line, the line means connectivity, and you can really see junction box, which are splice enclosures, net spider, which is topological view of the network, and so on. So there is also a bundle called C line that is available for the customers. We will take a look on the functionalities we've got here. And then we go to the more advanced modules where we can really grow our, let's say, potential functionality in the software from layer one all the way to layer seven. So that's really one of the key advantages of FNT. I've been working in this industry for quite a long time, and FNT not only will allow you to manage, let's say, your infrastructure, your physical connection, your logical connection, but it goes all the way up to the application level. So you know exactly what softwares are installed in each server, when you're going to have to update them, when your maintenance agreement is, it should be renewed. So all those capabilities are here. Power management for data center, air conditioning management, software management, as I was saying, telco, which is logical inventory management. I will show you those features in a minute. NC Gate. So these are the integration capabilities that FNT offers. So auto discovery, especially when we are dealing with the active network, bringing in the logical circuits and so on, and the physical configuration for all your active devices. So reconciliation engine and so on. So, all right. So now you know a bit about how the system is configured and the dynamics of it. Just want to, before start showing some functionality, the system works in different languages, Portuguese, Spanish, and some other languages here. So every user can customize and change the language to his own preference. All right. So, and the modules or the capabilities you use the most, you can mark them as favorites. So that means they will become here readily available. So one of the capabilities within CBase is the navigator. So what is the navigator doing for us? It will allow me to get any site I want to bring into my area right here. Let me just take one example here like this. And then once you get it, you can navigate down to, let's say, let's do the data center, Frankfurt data center. We get the hall A, we get the ground floor. So I see all the different floors within my building, and the ground floor has all the different rooms. So if I click on the room one, I can see all the assets and go down to a port level if I want. Okay. So this is the capability, the navigator that will allow you to hierarchically visualize your sites as well as your IT within each one of the sites and allow you to work and manage them from here, right? So like I got the different like areas within the data center. So the cooling. So I got here my cooling systems. I can also have sensors like cameras, fire extinguishers, and so on. Power distribution systems, so I can see the power buses and then check their capacity if I want. And it comes down here to the IT rack. So I've got here a few cabinets. So if I want to select any cabinet here and work with it, I can do so. I will show you in a minute. But I can go down to a card and see if there is services and so on. So we can also customize the information that will be displayed here, such as service, customer name, and so on. So the way we actually manage the information here is quite flexible, allowing us to cover most of customers' use cases. And if I want to create something here, I can just click and say place. So I would pretty much install a new cabinet. Or if I got a cabinet, I just need to copy and paste. I can copy and paste. So it's very easy to manage, as well as I can open the graphical view for a cabinet. So this triggers another capability of FNT command, which is called a switch cabinet. So I can see here, this is just one example. I'm going to be using a few other racks for the demo today. But you can see here the front side of the cabinet. You can turn on and see all the rear side and so on. So, and every port that is green here is connected. So I can click and see connections. It is as easy as I click here and show hide connections. So you can see that port is going to this port over here. So I can turn on, turn off. And switch cabinet will allow me to manage the actual port. So if I want to block a port for a customer, this is reserved for project A. So we can do that, and the port gets marked in red color, right? If I want to move devices, I can and get one thing here. Let's say this guy should be up here, so it will allow me to do so. I do like this case, it won't fit because it has some alarm from the back, right? And I like to run into those situations during a demo because I like it to be with great emotion. So, but I will be doing some use cases that will make sense here. But just so you keep in mind, it's really very powerful. The switch cabinet capability. And so that's the, let's say we see the 2D view of the cabinets, and we can bring more cabinets to be able to connect among them. So we're gonna have a list of additional cabinets in here, okay? So, all right, this was the navigator that I wanted to show you, how you can easily see your systems right here, and check all the different areas within your data center, like the telecom rooms. And you can also see here the number of assets within that specific room, okay? All right, so and then you can search here for other areas or other sites that you want to organize this. So now let's go back. So when you click here on the, let's say the left upper corner, you can go back to the main menu, and this is where it is. And this is the faster, the quick search tool. You can just click rack or any device, and the system is very responsive, brings you all the cabinets. So I want to see cabinet 1A open. So that opens another feature of the C-base capabilities, which is the object management. So for that cabinet, here I can see what is the manufacturer, what type it is. I can see serial number or any other details that I want to register. And every asset will have its own, let's say, detail form, which we call object management, with all the different information. Like, for instance, for this cabinet, I've got here power consumption, cooling, heat dissipation information, everything that will be used by FNT command to then create dashboards as you start creating your network within the system, okay? So you can do it for, let's say, for a switch. If I go back to my switch cabinet here, let's say this Cisco device, if I open object data, that gives me the object data for that Cisco switch. So I can have multiple tabs open at once within each one of the capabilities. And let's say this guy can see technical data and so on. So that allows me to explain another very key part of FNT command, which is we have a library with over 80,000 component types already available. Most of like large data centers are using FNT command, so which means it's like it's off the shelf. It's a very quick installation process because we can just download the models, whether it's Cisco, Huawei, Juniper, all vendors, even local vendors in different countries. We have seen that they are available, and not only we have all the graphical view for those devices, but also they bring us the standard information about consumption, heat emission, cooling, dissipation, weight, which will then be used by FNT to create those dashboards, which I'm going to show you right now. Okay, so where I want to take us now is to the data center cockpit. So I'm going to go DC Frankfurt here. And that's going to give me the Frankfurt DC. I'm going to open with, or this open, okay? So this is my data center. So here I got just information about how many levels. We got 3 floors, first floor, basement, and the underfloor, right? I do have here on the side the basic data, which is pretty much that. We got also the rooms. So in total, we've got 10 different rooms within the data center, right? In FNT command will also give me dashboard views of those rooms. So for example, here I can see for room one, the climate utilization, power capacity utilization, floor utilization, and I get to see that for all the different rooms within my data center. So I see here I do get a problem with room number 3. And as you start working with your inventory, you're gonna see that you get alarms, so you might not be able to install because you got power short on this specific circuit. So that's the powerful of having a DCIM solution like this. This gives me the view for each individual room, but here I can see for the overall data center. So I do have a problem here, which is I'm gonna do a workflow. You're gonna see I'm gonna get some messages. Um, we also categorize the different areas within the data center, so it makes easy for you to know, well, what room do I have more space if I'm negotiating a new agreement or a co-location agreement or any other type. You can see here what are the free areas, traffic area, device areas. That will also allow you to efficiently manage the floor space within your data center, right? Then we got capacity here, which is we got a planning module, so it shows us per zone, and then for all the different rooms, what is the current power consumption and what is the future power consumption when we get all the ongoing projects and merge then into the operational network, right? Then we got forecast. Forecast will give you historical view of how you are using your resources, how your power consumption is growing over time, how your heat emission is growing over time, which will allow you to get predictive analysis, get to know where you need to expand more and so on and so forth. So, and then there's going to be more thing here, even the history, so who changed it and everything. So every change is also logged within the system. When we go to a room, I can open with footprint. So that's going to be my room one. And I get to see the footprint for room one, as you can see here. So this is my 2D footprint, which allows me to click on a device, take actions, move it, and so on. So here I can really operate the data center if I am entitled to. You can always turn on, turn off layers, and then you can see the sensors, you can see underfloor and so on in your graphics here. But then it gets much better because we got the 3D footprint, right? This is where you have a real immersion on your data center. So you no longer need to go into your data center environment to feel as if you were inside and close to your operations. So this is really great. So this is the cockpit data center. It's also one of the key capabilities of the software. So you can get closer to one cabinet, adaptive view, and visualize it like that. See here power systems if you want to click. And of course, if you click on any device, you're going to have full access to check connections and work and so on and so forth. So this is let's say this is the data center room, right? Where we can see all this. Another thing I want to quickly show here, and I'm really being careful now about the time. So I can see the data trays, or we're gonna have data, or the power, where we got power cables coming in. So this is where we can turn on, turn off the layers. We can see like dashboards view, and this is what I really think is cool. So this is the view of my data center based on the rack unit utilization. So where do I get more space to install new devices? I can also have a view for the power resources. So sometimes I might have space, but the equipments that I have are consuming a lot of power, so I might not be using that one. And this all comes from the pre-existing library of FNT command. You just need to create a cabinet, put everything in, and there you go. You got your dashboards ready to use. Climate utilization, where I get more heat dissipation, where I need to take actions, as well as weight, right? So that might be important for your floor, right? Requirements. So where do I have very extra heavy cabinets that would make sense to reassign to other cabinets? So that's cool. You can see all that in here, right? When you are managing what we call the digital twin of FNT command. Then we got the heat map. So that's really cool because we can integrate with existing sensors. Like in this example, we get the top of the cabinet with 31. This is the temperature, which can be obtained in real time through sensors, or you can have an auditing process with your mobile system on. So that's really a live view of what's going on in your data center, and it's a very key feature of FNT command as well, the footprint for data centers or cockpit. Okay. All right. So those are things I also want to show you really quickly here a little bit about the footprint. So this is my room number one, right? I can go back to the data center. I do have an overall footprint here that will show me all the areas within the data center. I might zoom out a little bit so I can have also an integrated view. And the reason why I'm coming here is because in the underfloor, I've got the power and cooling system, right? So those are power and cooling systems, and I can just click on a device here and say open. The same way I open the graphical view, I can open switch cabinet for my battery panels, and there you go. From here, if you want to check connections, you get all the options. Where is this connected to, and so on and so forth. Okay. And I will show a little bit more about that. But if you go back to here, you see you get your generators, you get your cooling area. So this is perhaps a pump two. And you can track not only your power, telecom connections, but also everything related to your cooling systems, as our HVAC, condensers, and the airflow can also be documented here, as we're going to see in a minute. All right, so those are views you can get with the data center cockpit, which are really cool. I just want to go back now to run here and want to show one of our first like workflows that would make sense for this conversation today. I'm gonna adapt view. So that's my cabinet. I can open with the switch cabinet, which is where I have it, the view for doing anything or managing as I want here, the device. So let's create a new project. So I want to show you how easy it is to activate. So I'm going to create a new 1328. That's our protocol. So I'm entering the planning mode. So let me see here, like FNP webinar. So I can check the date here. Let's say I'm going to be doing this by Saturday, or I think I got to click on here. Cool. And I can say any status I want. So now I'm in the planning mode, FNT webinar. So let's say I need to install some equipment here. So I click place. I do want to be specific in this. So I want a switch. Let me do a switch. And I will get a Cisco device. So that's my preferred, since I have my CCNA. So I can, so see there is a threshold because it's warning me, air conditioning, cooling, your resources needs to be reviewed as well, not just keep installing devices in your cabinet. But okay, I'm done. I will review that later. And I will also add here like an SFP, right? Um, okay, so those are actually steps of my work order. So let's say now I gotta connect ports here to the port in here, 22. So as I click on the ports, I'm also able to connect them. Let me see if I going to be able to connect them. Yeah, it's gonna give me here like connections, just so I'm showing you this, which I think they are more compatible in terms of that. And you can see connections as you go. But let's say our workflow has these three areas here. If I exit the planning, so see this is blue color, then I'm back to the original. So I see there is something planned here. So I can plan to install, I can plan to remove. So now if I go to one of my C basis modules, which is planning, and I search for 1328, that's going to give me the protocol. I've got everything I need to do, install new device in the cabinet, install new card, and I'm able to assign, modify, change, add more steps in here. And more importantly, I can actually execute it. And keep in mind, everything in FNT is like can be a report. So if you can easily click here, and this is my protocol 1328 we just created, and we will be able to know exactly when we need to do what we need to do. And all these reports we can also customize with your logo and additional information you need. So now if I say, okay, let me say I already installed, so this gets in green color. And if I go back to switch cabinet and update the drawing, it's gonna give me that. Okay, so there you go. That's my switch over there. Then I can just go ahead and install the new card, plan to action, yes. Okay, and then this one here as well, plan to action, yes, cool. So that's when we can go back and see everything in here, okay? So there you go. All right, and this is like, just so you see a workflow, now I've got that and everything is established as I needed in my system here. So I want to also talk about the NetSpider tool. So NetSpider allow me to get like a topological view of the network. So I'll try to finish up this in 5 minutes. I think we did see the core, and we will absolutely be available to do like a specific demo for all of you with us today. But you see, this is like where I can see, this is like a live drawing where I can load cards and see how they are connected. And I can manipulate them. I can immediately see what the card looks like and so on. So we can build multiple views of even the data centers, how they are connected. It also applies to the, let's say, to the fiber to the home. We do manage that in a very efficient way. There is much more for F&T, which we could explore here, like power systems, cooling systems, and so on. I just want to quickly talk about the logical inventory capability. So not only I got the physical connectivity, but it will also give me the circuits and how they are configured in the network. So if I got a 10 gigabit over a DWDM, so all those logical layers of services can also be managed within FNT command, as you can see here in the software. So you get all the circuits and how they are related, right? So that gets me to a topic that I really want to talk about, which is when we get a cabinet like this, if I want to see connections, I get connections. I'm able to click on a fiber and see how it is connected and keep tracking connections. The other feature we can see, you can fully track the connection for a port. So if I click here, signal tracing, it gives me the full end-to-end connectivity view for that, not only for telecom, but we can also do the same. Like, is this power, where is it connected to? And this gives me the power connection from the PDU in a rack all the way back to the transformer. So it really gives me the full visibility for the data center, as you can see over here. Okay, so that's also a key feature I wanted to highlight, which is we do manage connectivity. Um, Also, FNT also has a GeoMaps module, which would allow you to efficiently manage your network, but now on like the outside plant. So it can be used for internal environments, data centers, but as well as for the fiber to the home, and you can map your network as you want. As you click on a site, you get full access from the map to everything that is inside. You get full tracking of services. So if you click on here and let's say I want to open the switch cabinet for this OLT, which give me this right here. And let's say port one, signal tracing, that's my OLT going all the way back. I can change the splitter port if I want, because this is a point to multi-point connection. And if I want, I can represent in GeoMap. So That's going to give me how things are portrayed on the map as well. So it's really reloading the map here, but would allow me to see where that circuit is actually connecting to within the FNT geomap system. So it does support 3D maps. It does support that you customize with your styles. And it's empowered by ArcGIS, which means it's Esri based, right? All right, so lastly, I just want to touch base on the data center or this one here, which is analytics. It's a module of FNT that would allow me to bring live dashboard views of all the different aspects of my data center. So, and as you click on a specific parameter here, you're going to get more details about that specific one. So you build live dashboards that stakeholders can have to manage their business. Like here, I can power capacity. It's gonna give me a full dashboard with the PUE, WE, all those parameters managed and easily available here. And as you click on a panel, you go deeper on it. I do have here the energy and cooling. I think this is going to give me those KPIs like POE, etc., which are very important. And you can select different sites and see. So I just want to see for room one, and that gets updated and so on. Like probe temperature. So this is more related to that. So there are really dozens of dashboards here that are amazing to really bring you updated information on your systems, okay? Um, I do want to open for questions now. If anyone has questions, I see there is no question in the chat area. I hope that's because this has been a very good and clear presentation to all of you. But any moment in time, you need some support from us to get more in the specifics of any feature. We're going to be available for you. So just since I said that and we got no questions at the moment, I want to show you the FNT Mobile, which is also part of the very good set of tools that FNT offers us. So if I say, let's say, I do have one better example. Let's search for a cabinet or a rack here. Oh, actually, a server. That's what I say in the ClickPath demo guide. So now I can click on the first server, and this is my HP server. I can see what data do I've got. So do I have information on it? So see, I do have one document related to it. So all data sheets, I can see it from the field. I can upload photos if I want or favorite, so it will be my first one. I can see all the details here, but it gets better when I see the switch cabinet. Okay, so that's so we were dealing with that. So let me see the switch cabinet. So it will give me that same view on a mobile fashion way, and I will be able to operate and manage here as I need. It is very cool because I know if you can also check for the server what how the connections look like. So so I'm in the field now. I want to track how connections are established, so I will be able to do so in here. It's gonna bring me all ports, and with that you can click on a port and really follow along with all the paths that are available in this very specific system here. Okay. It's taken a while, so that's, I think it's when we can um, finish the conversation for today. Those features, we can show it on a later time, so we'll be within time. Brian, you wanna come up to say hello or goodbye to the people? Let me just bring my slide here to finish the presentation. Give me one sec.
Absolutely, Eduardo. And thank you for taking us through the live demo. I think you did a fantastic job. And thanks again for having me and everybody for attending and giving us your attention and time. I hope this has been a meaningful learning session. And I look forward to hopefully having some conversations with some of you in the future as well.
Very good. Thank you very much, Brian, again for being here with us. It was a great pleasure to join you and FNT team. Thank you to our FNT team for sponsoring the webinar with us. We hope this will be the first of many others. I think topics were quite relevant for the audience. And we look forward for like mutual cooperation with all of you present here in the future. Okay. Thank you again for your time. And we see each other in the future. Bye bye.
Have a great day, everyone.